it's a bit, sorry, at the Parker Theater. But we're also joined online for some of you joining. This is live streamed through YouTube. So, my name is Bei-Chin Gao. I'm going to be the moderator for tonight. Took part in FameLab in 2020. Had a fantastic year. But also made it to the final, and it was a great experience. So, to start off, what is FameLab? Well, originally it was started by the British Council back in 2007, and it's a SciComm or science communication competition that's focused on really anyone from all disciplines, all degrees can compete, and the challenge is within 3 minutes to talk about their project or to talk about a scientific topic to the broader audience, with the aim of making science more accessible for everyone. And since then, it's been over 35 different countries, 9,000 different scientists have participated in this. And this year, we're adding to that count. So speaking of the British Council, tonight, we're very happy to have some guests visiting from the British Embassy. And in particular, we have Martin Gilbert here from the British Council. Would you like to come up and say a few words?
Thank you very much. So, hi everybody. I'll only speak very, very briefly, and I'll speak quickly so I don't take up too much time. So, welcome everybody here for the to Bern for the FameLab Swiss Final 2022. My name's Martin Gilbert. I'm Director of the British Council in Switzerland. I'd like to mention 3 things in my very short speech before the excitement of FameLab begins. So firstly, I want to highlight the strong relationship in science and research between the UK and Switzerland. FameLab was originally developed by the British Council, and it's fantastic that a very strong team of creative and dedicated people have now stepped forward to take FameLab on independently in Switzerland. Next, I would like to particularly thank some very special people who've made tonight possible. So first of all, I want to express my admiration and thanks for the essential work of Dr. Sylvie Kuprus. and her colleague Helen Stauffer. In making FameLab possible in Switzerland. I'd also like to thank all the team members from Basel, from the graduate campus, and Lausanne, Bioscience Network Lausanne. Finally, I'd like to highlight the continued support of FameLab Switzerland by the British Embassy and British Council. FameLab is a great event and it strengthens the bilateral relations between Switzerland and the UK in science and research. And in particular, it is a great place for young researchers to get experience in communicating their science to a broader audience. I want to wish all the participants the best of luck as they compete in the final. I'm really looking forward to the exciting, challenging, and fun presentations. Good luck, everyone, and have a great afternoon, great evening. Thank you.
Thank you so much, Martin. It's great to have you and the members of the British Embassy with us tonight. We did talk about the hard-working person behind making all of FameLab Switzerland work every year, but we should give a chance for Sylvie to come up and say a few words. Come on.
Thank you. I also myself want to welcome you warmly to this year's edition of FameLab. The final is taking place now. As already said before, I'm not the only person organizing FameLab, and the organizations have been named before, but I just want to thank you for working and collaborating with me and us on this really nice program. I enjoy this very much. And thank you all our jury members and our moderator for being here, and also our guests from the British Embassy. Thank you, Martin. Thank you all for watching us online, for the small but very nice audience here. Hopefully next year we can do it a big, nice event with you here instead of online. And now I'm looking forward to interesting, exciting, and fun science talks. And to the participants, the best of luck and enjoy.
Perfect. Thank you so much, Sylvie. And again, thanks for all the hard work that you've put in and the team for getting this done every single year. So, I guess turning to the competition, how does FameLab work? Well, if you look over there, the hardest thing about this is it's going to be 3 minutes only. So each of our contestants today have only 3 minutes to give their talk about a new scientific topic, and they will be scored by our distinguished panel of judges, who I'll introduce in a bit. And we're looking for not only 3 minutes, but also what we call the 3 C's, and these are the main criteria. So first of all, content. Is the content of it good? Is it interesting? Is it well communicated? Clarity, again, does it make sense? And finally, and often we say might be the most important, is charisma. So are they saying, are they getting their point across in a very exciting way, or are they very engaging throughout their 3-minute talk? So these are also the 3 that viewers at home or in the audience have to keep in mind as well, because not only is each contestant scored by the judges and the jury, but also at the end of the show, at the end of the competition, you'll have a chance to vote for the public winner. So keep that in mind and maybe get your scorecards out. I don't know. So speaking of the judges, let's give them a chance to say hi. Right. So first of all, I guess we'll start from the right. We have Nick Papajojo. Sorry. So he has a PhD in biomedical science and now works as a science communications for EPFL, covering topics like physics, chemistry, and life sciences. He actually also draws the upturned microscope, a comic that, in my opinion, sometimes captures the ups and downs of graduate school far too realistically, but always funny. And he's also written several short stories as well that's based around themes around scientific research.
A long time ago.
Yeah. But it's still there, and they're great. Yeah. So Nick's a fantastic science communicator who's managed to really bring science communication into different types of media. And welcome. Do you have any last words of advice for our contestants today?
Well, like I said before, well, first of all, thank you for having me back. And my advice is, from what I learned last year, is relax and have fun. That's what will get you there. All right? Don't stress.
Thank you. And next, we have Gabby Rockman, who, having originally studied visual communications in Düsseldorf, took a whirlwind career, right, through the advertising and marketing world. First as an art director, then being a consultant, and now owning an advertising agency of your own, advertising and production agency of your own. But in addition to all of these achievements, you have several different certificates, and specifically training in psychological systemic counseling, hydrotherapy, hypnotherapy, facilitation, and didactics. It's a lot of things. Sorry, I'll stop. But just in general, all of this makes her perfect for being a communications trainer, which is also what you do now. And since 2018, in Basel, she's been training participants with the Discourse program at Uni Basel, training scientists like some of us, actually many of us here in the room, on how to better communicate their science. So thanks for being here with us. And
my pleasure.
yeah. And do you have any last bits of advice?
I have. Yes. I have. Okay. I would like to say, enjoy yourselves and go for it. Yeah. Thank you.
Thank you so much. And then finally, we have Harini Lakshmina Ryan. Sorry. And she's Actually, for some, maybe a returning face. She competed last year at FameLab and made it to the finals. But she's a third-year PhD student working at the Institute of Pathology and Molecular Pathology at University Hospital Zurich. And her research is mostly focused on identifying novel biomarkers, right, for kidney cancer patients. Outside of the lab, you are now, she's now an associate director of the Open Innovation in Life Sciences Association and is an eager advocate for open science through communication and events like this and policy. So how does it feel to be back? And do you have any last words?
So first of all, thank you so much for having me back. It feels quite different, I must say, to be sitting on this end of the bargain. They've already given you all the good advice they can, but if I have to tell you one thing that might be obvious but not so obvious, breathe. You'll be fine. You'll get through the 3 minutes and you'll do a good job. Good luck.
Thank you so much. And yes, a warm welcome to our 3 judges. And breathe, breathe. We're all good. Slowly getting there. Everyone's getting a little bit nervous, I can see. But it'll be good. So, after each contestant has their 3 minutes of their presentation, we'll give the judges a chance to ask them some questions before we move on to the next one. And again, for some of the viewers in the audience, those on the live stream, pay attention because you also get to vote near the end to decide who wins the public winner's vote. And of course, we do that through Mentimeter. We're not gonna activate it now, just to give everyone a chance to tell their story, give their talk. But at the end, we'll be using Mentimeter to find out the winner of the public vote. So, are we ready to start? Are we excited? Woo! Yeah, gonna sit to some really, really cool science. Oh, actually, I think I might have missed a slide. I apologize. But before we start, it's important to thank all of the sponsors and the supporters who have really helped make this possible, especially the ATH board, who have really provided significant support in bringing FameLab this year. And of course, all of the others you see up there, including these wonderful Swiss universities, the bioscience networks, and the life science networks of Zurich and Lausanne, and of course, the British Embassy, who's here with us tonight. So, tonight, there's gonna be a little bit of a flow through all of the talks. I wonder if you can, no, I'll just spoil it now. But we're gonna move on from something that's, basic medical sciences to, what is happening in the labs, onto some talks about fascinating new technologies. And then finally, we'll close with some of the larger topics, like how do we tackle climate change? How are we tackling, making sure that we're healthy in times of a changing world? So, without further ado, let's start things off with a flourish, right? First up, it's Andrea Vucicevic. I'm so sorry. Who's a doctoral student at the Faculty of Biology and Medicine at Université de Lausanne. She's studying molecular microbiology, loves playing with various different forms of science communication and reaching out to get people interested in what she's doing. I won't spoil anything, but I think we're in for a good start with her talk, Symphony of Life.
I'm ready. You know when you are in a lab and you're just fascinated how cell molecules reacting to the surrounding signals communicate and cooperate with each other to create all existing life forms. Inside every living cell, whether it's plant, animal, or bacteria, there is literally an ongoing concert under the conducting baton of environmental stimuli dictating rhythm to the gene orchestra to play all kinds of symphonies so the cell can dance. it is an orchestra, it means that every gene has its turn to play, and some will initiate other genes' turn. For example, regulatory proteins, encoded by some genes, will trigger other genes to play their keys and notes. So I'll take this cell culture into the incubator. But before, I shake a bit an Erlenmeyer. And it's like I'm hearing this Symphony of Life. When every cell divides, going through life phase and it dies. But before it dies, cell is dancing through life stages. 'Cause regulator proteins are playing their genes like piano, yes, yay. Yes, they can change, they can play, they can change. Cellular shape, cell response, they can change if they properly fold, if they know how to hold. Promoter sequence is a place to enhance or suppress gene expression. Yay! Cardiac cell, muscle cell, neural cell. Signaling paths will ring gene, jingle bells, and there are a million different melodies to which cell can dance. What is yours? What is yours? My microphone, I knew that it will drop. But it's okay. Yeah. Okay.
Yeah.
There was a part, and I did already hard, but it means I love you. Thank you.
Okay. That was quite the start. That's
Yeah.
amazing. And also a few dance moves, right?
Yeah, few. Yeah.
So, I guess we should turn to our judges and see what they think. First, Gabby looks like she's super into it and is humming along.
I
So-
couldn't help it. It just happens. I couldn't help it. It just happens. Listening to you, and wow, thank you very, very much for your dynamic start here.
Yeah.
And it was just amazing to see what happened after you introduced your story.
Yeah.
What I would be interested in is, you said you use stimuli to get the dance started. So is it always the same dance when you use the same stimuli?
No. There are
No,
million different.
So different choreographies.
Yeah, there are million.
Yes, you can sing it, please.
Yeah, the last part of the performance says everything. Yeah. There are million different dances.
Okay.
Yeah.
Okay. So different dances to different.
Thank you. Yes.
Yeah.
More than million. Yeah.
Oh, great. Thank you very much.
Thank you.
And I hand over to who? Yeah. Okay.
So I'll be asking the science questions.
Yes.
So what is your PhD work specifically on? Just very quickly.
Yeah, actually, that was the source of my inspiration.
Okay.
Because I investigate mobile genetic element in environmentally friendly bacteria that actually digests toxic compounds that we consider toxic, but it has these genes that code for the metabolic machinery for this to metabolize these compounds are on a mobile element, and this element just in 3 to 5% of cells activates and transfers to another cell that doesn't have this ability and helps that this other bacteria becomes capable to degrade this toxic compound as well. So I just found it amazing how actually we still research what is the main trigger of this transfer, and it's composed of the cascade of the activations, gene activations, and it reminded me like transcriptional factors that activate other genes, and then it's like a piano with the fingers. Okay. And to me it looked like a symphony of life, really. And it just brings something that makes cell behave differently. Yeah. And I compared it with dance. Yeah.
Thank you. That's a very evocative image. Thank you.
Thank you. Yes, thank you.
I must say, I love the performance. I can imagine your cell culture is a fun place to be in with you.
Thank you.
I have a question along the lines of a bit more scientific, or science communication, let's say.
Yes.
Working with bacteria and doing a PhD in itself is not something that everybody relates to, which is also why you're communicating science here, right? So what part of your project or your involvement in understanding the science and your PhD in studying the bacteria do you want to communicate, and what do you find difficult when you talk to somebody about communicating about bacteria? You can't really see it, so.
Yes, what I found working with students, it's not only someone who is a family member or someone who just came to hear about science and it's out from science, but actually scientists, the young scientists, they have maybe troubles to understand better some molecular mechanisms or how does it work. And really the way how you are going to communicate this will help a lot. First of all, psychological state of the scientists to continue and to see this as something very normal, like we exist now and interact. It's the very same way how molecules interact, and it's just as simple. So we need to communicate science that way. And that is I just saw students and I was inspired to bring them complex topics, simple and fun as they are. Yeah.
Thank you.
Thank you. Yeah.
Yeah. Thank you so much to the judges and Andrea for taking us off to such a crazy start. Next, we have Adele Nirina. Yes, who's a doctoral student at the University of Geneva in pharmaceutical technology. Trained as a pharmacist, she actually participated last year and gave a great talk on sort of the gut microbiota and all of the advantages that it has. But this year, she's back to continue to challenge herself and push further with her science communication journey, right? Adele 2.0, if I might say. And today you're talking to us about a drugs odyssey. No.
I have a headache. You see, I already took an aspirin tablet, but it's been 4 hours and I had to take another one. But hey, have you ever wondered why you should take medicine several times? No? Well, some people argue it's for the money. Others say it's to bother the patient, and skeptics preach that it's a conspiracy created by pharma lobbies. In fact, your body. Now I need you to picture yourself in your sofa. You're swiping through Tinder, and boy, does it give you a headache. So you decide to take an aspirin tablet. The tablet goes to your stomach. It has to withstand the gastric acid, and when it gets to the small intestine, water will dampen the tablet, it swells and disintegrates. Now, brave little molecules of aspirin will travel through your whole body to rescue your head from its pain. But there's a plot twist. You see, drugs love open relationships. So for sure, it will get to its rightful target, its soulmate, if you will. But this little flirt wants to explore its affinity with others. And sometimes the matching goes well. For instance, aspirin can also fluidify your blood and prevent clots. But as Tinder proved it, most matches are toxic. And this is what leads to side effects. You must all have experienced stomach ache from aspirin by now. So how do you take care of these toxic matches? On Tinder, boom, you block them, and the system gets rid of a problem. In your body, the liver does that work for you, and it does not discriminate. It eliminates both good and toxic matches. In fact, it chemically transforms the drug to be eliminated through urine until there is no drug left in your body. Now, you've been a few hours on Tinder, there are no matches left in your area anymore, and your headache is back. But keep calm, take a new aspirin, and keep swiping.
Amazing. And this is not at all the product placement for Tinder, right? No.
I think Tinder should make a partnership with aspirin right now. I think we've got something.
Can we get people on that? Is that possible? All right, let's go see what the judges think. Harini, you seem like you were.
Thank you. That was a very enjoyable talk.
Thank you very much.
It was a very easy to understand example, let's say. So, in your PhD, right? So I want to assume you do something with drug discovery. What do you do?
Well, actually, it is not about my PhD at all. I'm here just to communicate about science, and I'm a pharmacist. So to me, when I get people coming to the pharmacy not knowing what happens with their medicine is something I would like to put light on and explain a little bit more. But my PhD is actually about fecal transplants. So
That took a twist.
yes. Yes. It's not the same thing at all.
Okay, great. So, as if I can just quickly follow that up. Okay.
Yes.
So you said you'd like for people to understand what drugs they're taking. We just went past 2 years of people popping pills, not popping pills.
Yes.
Did you see a role for yourself when you were trying to talk to people in your life about COVID, about medication for COVID?
Well, actually, I'm very fortunate that my entourage is, they trust me enough to listen to what I say. But I've heard for some friends of mine who were trying to explain things. I have people in my lab working on vaccines, so they got they got their work cut out for them. But it was not really easy. And when I tried to explain what I thought was fundamental for me as a pharmacist, but which is not the case for most people, I found myself explaining basic immunology to people, and actually people are quite open to understand these kind of things, so here I am right now, I guess.
Well, I mean, I was going to ask what Harini just asked there about that, but I got to say, I've never heard bioavailability being matched with like Tinder. That was very clever. That was very good.
Thank you very much.
It keeps attention. Can I just ask if you work on fecal transplants? You
Yes.
said. Do you do any work on bioavailability of drugs and changes following fecal transplantation?
Oh, that would be very interesting, actually. But I'm in a pharmaceutical technology lab. So what I'm doing, to be really simple but a bit crude, is to make people eat poop. That's my job.
Just like Tinder, basically.
You see, Tinder, please sponsor me. So what I'm doing is trying to make fecal transplant more pleasant and more easy for people to take in the hospital. So I'm not on the bioavailability part, but that could be for the next person who will be working on this project. Who knows? Thank you.
So also from me, thank you very much for your vivid talk. Really enjoyed it.
Thank
you. Tinder and headaches, so I know what I'm not doing. Okay, then. Okay, I have a more broader question. So what was the most surprising finding in your research when you started with the fecal
Transplants?
transplants?
Yes.
Yes.
Ooh, everything is so incredible. So I would not be able to pick something, but to be fair, being able to create a technology that to summarize, right now people are taking a huge volume of poop as a treatment. So yeah, just the fact that I am able to do some microparticles with the fecal matter, and that I am able to dry it, and that the microbiota inside stays alive, that I have still the same composition of the microbiota inside my little beads. When I saw everything coming together, I was like, wow. So a PhD is actually. So I would say that.
Okay, thank you very much. I can see
Thank
that you are burning for it. It's great to explore. Thank you.
Thank you very much.
Thank you. Thank you so much. Also, that's. I mean, next we have Celine, who's standing there with a very interesting item already. I can't wait to see what you'll talk about. But Celine Berger is a doctoral student at the Institute of Forensic Medicine at the University of Basel. She's fascinated by research in biomedical engineering with a specific focus on forensics. And with science communication, she's here to push herself out of her comfort zone and to become a better science communicator. So let's have her come up and tell us more about how to revolutionize time of death estimation.
Thank you. My research starts at a time when most research stops, which is at the time of death. To explain you exactly what I do, we have to start at a crime scene. So we are now in the living room of him. He has been found dead in exactly this position 1 hour ago by the police. In these situations of an unclear death, forensic medicine comes into play. It is the task of forensic medicine to determine the time and the cause of death. So the medical doctor here will examine his body and check especially for third-party effects. Then the medical doctor will estimate the time of death, as nobody knows when he died, and as this helps to clear the course of his death. For that, the medical doctor will measure the rectal temperature, as the body temperature depends on how long he has been dead. This is because the body temperature starts to cool down after death due to the missing temperature regulation processes in the body. And as this process is similar in all human beings, the time of death can be estimated by temperature with a general model. So the time of death can be estimated based on a general model. However, it still depends on some individual factors how fast the body temperature cools down, like the body composition or the body weight. And these individual factors limit the time of death estimation. So the medical doctor here will only provide a time window when he died, but not an exact time point. And this time window is about 8 hours long. We aim in our research to reduce the uncertainties of the time of death estimation, so to narrow the time window when he died. And we try to do this based on the fact that the brain temperature estimates the time of death more accurate compared to the rectal temperature. This is because the brain temperature cooling does not depend on individual factors, and so it is more similar in all human beings compared to the rectal temperature. And therefore, a general model is more precise based on the brain temperature than based on the rectal temperature. Nevertheless, as you can imagine, it is quite brain temperature. But we found out that the brain temperature can be determined based on the forehead skin temperature, as the brain temperature cools down via the forehead skin. So we aim to revolutionize the time of death estimation by using the forehead skin temperature instead of the rectal temperature. So the medical doctor in the future will hopefully measure the forehead skin instead of the rectal temperature to estimate the time window when he died. So my research starts at the time when most research stops, but revolutionizing the time of death is of high relevance. Thank you.
Wow, that's an amazing, it's such a cool project. But also, is it ever scary, or do you just, does anything scare you anymore, actually? You've done FameLab, you work with this?
Well, I mean, there's sure cases which are quite difficult, but that's our job.
But that's fascinating. All right, let's go to our judges. Nick?
Sorry, for some reason I was expecting that microphone. I'm sorry.
You can also...
So question number one, how many people go missing in your lab every year? No? Okay. We can talk about that later. All right.
Maybe that would be better, yeah.
So, very fascinating. Question, if somebody has had brain damage, though, like been shot in the head or something like that, how does that affect the cooling of the brain?
For sure, then we can't do it based on a model, because then the brain temperature cooling is totally different. But then, of course, the rectal temperature would still work. Okay. But on the other hand, we would then have another option if there was a damage in the core area of the body, because then the rectal temperature.
Okay, all right. Can I ask one more? Okay, so just very quickly on your actual methodology, are you based on crime scenes, or do you go to palliative care hospitals and ask people if they can wear a temperature thing?
So it's based on crime scenes.
Okay.
So I work at the Forensic Institute, and so we just have those cases which are unclear and come to our institute.
Okay, all right. That's sorry, it's really fascinating. But
Yes. So you work with dead bodies.
Exactly.
Wow. Okay. Thank you very much for these amazing insights here. Well, help me to understand, why is it so important to find out exactly about the temperature? And
so to be honest, I'm actually working most of the time on magnetic resonance imaging. So we do post-mortem MRI. And the issue there is that it is temperature dependent. So if you do a normal in vivo sequence from the MRI on post-mortem cases, you won't get the same contrast. So then we started to get interested in a temperature, and this project is more of a side project of mine when we started to think about why don't we use the forehead skin temperature for the time of death estimation.
Okay, thank you very much.
Thank you.
So maybe I have two questions. The first one leading off where you left the answer to Gabby. I've never heard of an MRI for a dead body. Why do you do this?
So MRI, I mean, in general, CT scans are used in forensic medicine. And MRI would really help to see like soft tissue damages, and this would really help to do a triage system. So we would then do a CT and an MRI scan and try to even find the cause of death in the first place. And so we could replace some autopsies and check more cases. Because until now in Basel, there are prosecutors which decide if it's an autopsy or not.
Okay. My second question is more, so as an ardent fan of true crime series, how accurate do you think forensic representation is in media? I mean, so you have a lot of these series where they claim many things about death and...
So how...
So how accurate do you think the communication, the science of forensics in these series is?
Well, it's quite difficult. I mean, in the series, sometimes it's quite accurate, to be honest, in some series. But yeah, most of the time you imagine they go there with their high heels and check the dead bodies, and that's not how it works. So.
Okay, thank you.
Thanks so much. Again, fascinating talks. And actually, to stay with the brain theme, I guess, we have Florence Steiner coming up next. So moving on to cool uses of innovative technology. She's a PhD student at UZH in cognitive and affective neuroscience. So she studies emotional voices and their influence on the brain. And that sort of combined with this constant presence of films and art, movies growing up, it's really fueled her desire for science communication, and she's here to push that forward and challenge herself. So we'll have her talk about Dear MRI, what's with the noise?
I know what you're thinking. This is quite cool music, and it's not annoying at all, right? Fortunately, it's not music. But if it's not music, then why all the noise? Well, if you've ever been in an MRI, then you probably remember the very loud noises. And if you've never been in an MRI, well, this was just for you. In real life, though, it's much more loud. The volume can go up to 120 decibels, which is about the loudness of a plane that's starting. People describe it as thumping or hammering or ticking, but whatever you describe the noise with, the question remains, what is all the noise about? And to answer that question, we first need to understand what is an MRI. And MRI stands for magnetic resonance imaging. And simplified, those three words stand for three different components that help to create the image. So let's look at them. Magnetic. The MRI uses the fact that hydrogen is very common in the human body because we're made up about 70% of water. The hydrogen's nucleus is one single proton that is spinning around its own axis like the Earth's rotation. And just like the Earth, the proton has a north and a south pole, so it's like a tiny magnet. Now, I'm blanking. So it's like a tiny magnet, exactly. And these rotational axes of the protons, they are usually very randomly directed in space. But in a magnetic field, like in an MRI, they all start to line up. Resonance. Now, after lining all of the protons, they are flipped away from the main magnetic field by a burst of energy. That is a radio wave. And importantly, the frequency of that radio wave has to be the same as the frequency of the proton spin. They have to resonate with each other. After the flipping, the protons start to realign with the main magnetic field. And this happens at different speeds in different tissues. And this tissue-related relaxation time is what we use as signal. Now we only need to know where are we in space. And for that, we have three different magnets that have a temporal field that increases along the three spatial axes, x, y, and z, in magnetic strength. So each point in space has a specific magnetic strength that defines the location in space. And these magnets, they make the loud sound because they are continuously switched on and off. So in the future, if you're annoyed about MRI noises, maybe use this knowledge to choose to rather be amazed by that we are able to see into our bodies just because some tiny hydrogen atoms are quietly but continuously pirouetting through life.
Good job. That's amazing. But also the start, the like, I don't know about anyone else here, but I immediately thought of an alarm clock and had this moment of like, oh God, am I dreaming all of this?
Yeah, there's very different sounds as well, actually. That was just one example. I'm not sure if I even, did this very well, but it serves as an example, so.
Well, next time we can bring the full machine in.
Yeah. Maybe that would be easier.
Yeah, exactly. All right, time to go to our judges. Gabby has stars in her eyes, looking at.
Yes, I'm still processing. Yes, thank you very much for your talk here. It was very interesting because, yes, when you said the word MRI, I immediately felt myself within such a tube. And yes, I know what you were talking about. Okay, is there an alternative? Is it possible to reduce the noises somehow? Because as I know, it's not possible. It is because of it works like it should work.
Yes. There apparently, which is what I found out now while also researching a bit, are silent MRIs that have a bit of a reduced loudness, but apparently their resolution is not that well. So
okay.
I think it does exist, but
Okay, you have to make a decision.
yeah, exactly. And
okay.
so mostly you obviously choose the noise
Yeah.
because you want the resolution, because that's
Yeah.
more important.
Yeah.
And people also can get, if it's too much for them, they can also get sedatives. If it has to be, you get headphones mostly, or you have to get headphones actually, otherwise your hearing is disturbed afterwards.
I could demand a sleeping pill beforehand then?
I mean, I never
I tried.
gave it to anyone, but I think you could try, yeah,
Okay,
if
I
you
tr-
want to.
I'll try next time. Thank you.
I feel like I might again steal Nick's question. It was a really nice presentation. Thank you for. I've never had an MRI, so now I can be wary when I do get one. So, what do you do in your research career? How does MRI tie that?
So I actually use functional MRI. That is obviously based on this MRI technique. It's a little bit different, or it uses another physical principle. And with that, I research how we perceive emotional voices in the brain. So people go in the MRI scanner and they hear different emotional voices, and then we just acquire the functional activity in their brain. So that is how I use the MRI. Initially I wanted to explain like MRI and functional MRI, but that was already too little, 3 minutes. So yeah, I just focus on MRI because also a lot of people can relate, I think, because a lot of people had MRIs in their lives.
Can I follow that up quickly? Okay. It's super interesting what you said about hearing emotional voices. Can you maybe quickly, in a sentence, if you can, explain what hearing emotional voices mean? How do you hear emotional voices?
Well, there are different brain systems involved, obviously. For once, of course, the emotional system. That is is like located inside the brain, not on top of it. It's called the limbic system. I don't know if you've heard of the amygdala or the hippocampus are part of it. And then additionally, there's also, of course, you need to perceive voices. And that is, for example, is this on? Oh. Is it thing on? That is, for example, on the side here, which we call the temporal lobe. This is a very big area where we perceive voices. And then it's also very different if it's like angry voices or happy voices, what additional areas are also involved in that. So it's different systems, basically.
When we create inner voices, is it the same area of the brain where it takes place, or is
that
it
is a
different?
good question, but I don't actually know that. But what I know is, or what I've read before is during if you have auditory hallucinations, that then similar areas are actually active. But I don't know about the inner voices.
Yeah, I mean, even if you read a message from someone, a text message, you have this sound of a voice or
exactly.
the voice.
You imagine how you
exactly.
speak it.
And you
I don't
hear
actually know, but this is interesting. I should look this up.
Okay, yeah, thank you.
So you work with fMRI in
Yes.
your regular work,
Yes.
and you're looking at emotional responses to auditory signals. Is that
Exactly.
it? Okay. Do you work only with healthy patients, or do you look at that in the context of disease?
Yes, only
Okay.
healthy patients.
Okay.
Yeah.
So have you found anything fascinating so far? Anything interesting?
Of course.
Of course, naturally. Yeah.
Well, yes, because so my experiment is actually that so far in emotional voice research, you just used pre-recorded voices. And my PhD project basically tries to make it more interactive, because in a real emotional communication, you and I would interact, and I would react to you and back. And so we tried to make the experiment a bit more interactive by actually analyzing the brain signal in real time and sending that signal to an actor that then actively, like live, modulated their voice to increase the brain signal in participants. And I mean, this is still very complex, obviously, because they just saw a bar moving and not like a face or anything. But in the first experiment, this actually worked quite well. And then, which is actually where we focus on the amygdala, just extracted the brain signal from there. And then in the second experiment, we looked at the connections between the amygdala and the hippocampus, which is, I haven't analyzed that yet, but it worked. So yeah, it's just a step into a more interactive research, especially in emotion. It's important.
Just a comment. Have you got a video of that, like a little sort of 30-second whatever video showing that whole process with the actor? Because that would be a fantastic way to showcase your research on YouTube. I mean, that would just blow people's minds.
I've actually started one, but I don't have yet one.
Okay, I'd get your communications office to do one. That is, I would be all over that at EPFL. If we did that at EPFL, I would be all over that. Yeah.
I'll note that. Thank you so much.
Thank you so much. And yeah, so I guess we'll all look out for the video that's to come. Yeah. So next, our next speaker actually. Is that me? I don't. No. It's all right. But our next speaker has actually told us maybe he needs a bit more space up at the room. But this is Khushdeep Shama, coming from a PhD student at the Swiss Federal Laboratories for Material Science and Technology. I think that's the full name. But he has an interest in science from a materials point of view and is fascinated by all of its uses, right, coming from very technical to everyday life. And actually, he's here to talk to us about all of the sort of fascinating different materials that we see day to day that we might not think of. For example, a wonderful, soft, and flexible material, silicone.
So it's not about cucumber we are talking. We are going to talk about this nice, soft, and flexible material. And at some point in your life, every one of you have used this material. So ladies and gentlemen, this is one and only silicone. It has many applications in our life, like we use it because the material is bio-inert, so we can use it for medical implant applications, we can use it for LED and lighting applications, we use it in our homes for baking cakes and muffins, especially here in Switzerland. So what is the secret? Like why we can use this material for so many different applications ranging from robotics to medical? The secret lies in the chemical structure, the bond of love between silicon and oxygen. This bond, when repeats, it gives flexibility to this material, so that's why we can stretch. And the chemical nature of this material makes it soft. And now, the interesting thing is, it can exist in two different forms. So naturally, silicones are liquid in nature. And this explanation comes here. So these noodles kind of structure. So you see all these random noodles. So when it has a noodles kind of structure at the molecular scale, which we cannot see with the eye, then it's liquid, so like a lubricant or an oil. But we can glue these noodles by a special reaction. You see here, these red dots, and then this becomes solid. So we can use it for packaging applications, like when we cut the fresh vegetables, we can pack in it, reuse it, and yes. And now I leave it up to you all to explore the silicones that come across your everyday life. Thank you.
That's amazing. There's so many different applications. Would you say then that silicone or silicon and oxygen swiped right on each other on Tinder?
No, I'm not into Tinder, so I don't think so.
All right, let's go to our judges.
already. Thank you so much. It was a really nice presentation. I enjoyed
Thank
it. If I can ask you, so this is, you said it's silica and oxygen essentially reacting to form silicon, right? So can you comment on how you can either repurpose silicon, reuse it, recycle it, or if not, how do you handle it as a waste material?
Yeah, actually the material, if we use in a solid form, like I have here, so it's a emerging application for packaging, because you see this structure, when these noodles are glued at the molecular level, so then it becomes solid, otherwise it's a liquid. And this glue molecules give it thermal stability to almost in between 200 to 250 degree. So that's why if we have a mold for baking muffins or for making a cake, we can reuse it again and again, because this bond don't break at these temperatures. And the other kind of plastics could melt if we use. That's why we don't use, we prefer this. Second, it's inert, like it don't chemically react with many daily life liquids that we come across. So that's why we can use it. So it's reusable if we as comparison to the normal packaging, thermoplastic packaging. So you can use it multiple times, wash and use. So, yeah.
And when we discard it and it goes to a landfill, what happens then? How do you get rid of silicon waste?
What was the first sentence of the question?
When it goes to a landfill, like let's say you're done storing your vegetable and you throw it in the trash and it goes into the ground.
Yeah, so
then what
basically
happens?
it's very inert, so it don't react with anything. But now they are developing this recyclable silicone in which they can break the bonds. And this is called, I think, supramolecular chemistry. I'm not a chemist, but this work is on its way, because I think it's also the part of the future.
Super, thank you.
Thank you very much for your engaging talk.
Thank you.
Enjoyed it lots. Would there be a world possible without silicon?
Nowadays, I think it's a bit hard, because we have many applications. So there are a lot of automotive parts, like in your car, that are also made up of these silicons, because we cannot see them. So I think it plays quite a major role, also helping a lot of like in the medical applications also. So for example, for the breast cancer related application, there are implants that help. So
it's everywhere.
I think it could be possible, but it will be a little bit hard.
Okay, and there's no alternative, obviously.
Alternative, I have to research about it more.
Okay.
But right now it's really good.
Thank you very much.
I just had a hello. I just had a question about your research at the EPMA. Specifically, what's your project on?
So the project is basically on development of optical sensors, and this is one of the material that I also cover, and it's really like fascinating, like how much things you can do. So I can make it soft to hard depending on what application I need. And then basically at Sangalan we are developed this optical sensors that can be integrated into a textile to sense different kind of human activities and monitor, like specifically I am focused on the pressure. So we can prevent the pressure ulcers non-invasively for the humankind, or for paraplegics especially, or the patients who are on the bed. So it's quite a challenging problem.
Thank you very much.
Yeah, thank you.
All right, thanks so much. So next we have Natasha Hedrick, who's a postdoc at ETH Zurich in physics. Born and raised in Canada, she made the jump to Switzerland, where she did her master's at ETH, moved on to do a PhD at Uni Basel in quantum sensing. And now as a postdoc, she's working on a special project as an exhibit on trapped ions with the Swiss Science Center Technorama. So I guess we're moving deeper into the molecules and getting into quantum. So we'll have her talk to us about quantum tunneling. See you on the other side.
My glasses. You know that moment when you put something down, you're sure you put it there, and the next moment you can't find it anywhere? Or maybe it pops up somewhere completely different. You know, a lot of people come up with crazy ideas to explain why rather than blame it on their own forgetfulness. But me, being a physicist, I like to blame it on quantum tunneling. Quantum tunneling, you ask? Oh, let me tell you a bit about it. So we live in what physicists like to call the classical world. That means the laws of physics that we typically learn in school, gravity, friction, equal and opposite forces, govern most of what we see and do in everyday life. According to classical physics, it is impossible for an object, like my glasses, to pass through a barrier, such as a table. But in quantum physics, well, that answer can be a bit different. So in quantum physics, small objects, particles, such as atoms, though they're well defined in classical physics, they have size, mass, velocity, well, defining them in quantum physics is not so clear. It turns out we can also describe them as a wave. But unlike waves that we know, such as water waves, where water goes up and down, these are probability waves. That means there are certain points in space where you have a high probability of finding that particle, and other points in space where you have more or less no probability of finding that particle. And so what happens when one of these probability waves hits a barrier? Well, if that barrier is thin enough, there's some probability of that particle being on the other side. This might sound like magic, but it has some real-life consequences. In fact, it's the only way we can describe why the sun burns. In the sun, two hydrogen atoms have to combine to form helium, produce energy, heat, keeps us warm. But classical physics tells us that these hydrogen atoms don't have enough energy to do that, to combine to form helium. And this is where quantum tunneling comes in. The hydrogen atom actually tunnels through the barrier, which is the repulsive force pushing these two atoms apart, in order to fuse to helium. However, this probability is still really, really small. The only thing that saves us and keeps the sun burning is the fact that there are so many atoms in the sun that this still happens on a regular basis. But for an object like my glasses, that means that that probability is so small that even if we waited the lifetime of a universe and longer, with almost 100% certainty, we'd never see it happen. So blaming quantum tunneling on my forgetfulness, maybe not the best excuse. But it's still, oh, look, my glasses.
That's amazing. And also, I'm totally using that excuse. I know you just said it's not possible. Never say never, right? So I think our judges are all writing their comments. Any thoughts, questions already?
I've got questions. Okay, so this microphone doesn't. Could you see us without your glasses on?
I could not see anything.
That's why you're so calm. That's why you're so calm. Very good. What do you work on in terms of quantum tunnel? What is your particular?
So in terms of what I work on, both my PhD and now my postdoc, it doesn't have to do with quantum tunneling per se. But I mean, everything that I've done sort of since my master's has had to do with quantum physics. And so, I mean, at first I looked at tiny defects in diamond in my PhD, which we can call magnetic fields. Now I've switched to single ions, single atoms. And so everything happens on this tiny, tiny world, which is the quantum world. And so you have all of these crazy effects like quantum tunneling, which is really fun to tell people about because it just sounds so fantastical, but actually has these sort of real life consequences that we never think about. Yeah.
Thank you very much, Natasha. Oh, wow. Okay. In a time, 10 years from now, no, let's say 20 years from now, how would the research of today then will be affecting our daily life in the future?
That's a fantastic question. And I think, I mean, who knows what's going to happen in the next 5 or 10 years? But I mean, one thing that a lot of people are working on, I mean, we are right now in this sort of quantum revolution 2.0, where everyone's trying to build quantum computers, right? And obviously, all of these quantum effects play a very important role there. Whether we will have quantum computers that, you know, laptops in 20 years, I would say unlikely. But for sure, this is going to play an important role. The more we can understand how things work at a tiny scale, the more we understand about everything. I mean, just the fact that we can even have cell phones or laptops is due to the fact that we can understand, you know, how single electrons pass through electronics and this kind of thing. So, yeah, no, it's going to keep revolutionizing the way we work and how we interact with technology. But I'm very excited to see where it goes, yeah.
And step by step, I guess.
Exactly.
Exactly. Thank you very much.
Thank you. That was a really nice talk. I must say, as a biologist, physics is not something that I probably understand as well as a biologist. I see Vakshan nodding away in agreement. Can I ask you, so have you already had a bit of communication with your research field, specifically quantum? Because physics can be a bit, especially quantum, not so tangible, right?
You're absolutely right. That you struggle with anytime you talk to people that don't have experience in physics. Usually the first response is either I didn't really like physics in school or I did really like physics, but it was just too hard. So, yeah. I think part of the project that I'm working on right now is really interesting in that regard because I get to talk to a lot of different people from different backgrounds, different ages, and trying to sort of make this more tangible by, for example, people to actually see single atoms by eye. And this is something that hopefully we can bring this more and more into sort of daily experience to show people that, yeah, the quantum world can have weird stuff in it, but it's actually not that far off. So, yeah.
Luck with that.
Thanks.
Yeah, it's true. I was definitely nodding as a biologist. Physics is scary sometimes. So next, we have, well, going from the sun, things about Earth, our worlds. We come to the larger topics. So our next speaker is Temitope Adebayo, who's a PhD student at the Swiss Institute, Tropical and Public Health Institute, working in epidemiology and public health. And her interest is actually studying the short-term effects of air pollution, trying to come up with a better air quality index. And she's no stranger to science communication, right? She won the Science Flash Talk back in 2020 at the Swiss Public Health Conference. So can't wait to see your talk on protecting human health. Protecting human health from air pollution.
Thank you. Ladies and gentlemen, let me introduce you to Cindy. Cindy is a 16-year-old girl who lives in South Africa, about 10 kilometers away from an active coal mine. And Cindy also suffers from asthma, which means she makes frequent visits to the hospital due to the varying levels of air pollution in the area that triggers a condition. And this is quite a burden for her and her family, mentally, physically, emotionally, and financially. And she spends more days out of school than being in the hospital. So what can we do for Cindy? One would think, yeah, we can just shut today, but that is a bit extreme. We can't do that because the government cannot bear such economic loss just to save lives. Well, that's where we come in and we say, how about we develop an indicator that tells us what the air quality is and the risk of that air quality on every day. So For us to do this, we need to first ask ourselves, what do we know? And what we know is that there is abundance of research to show us that there are criteria pollutants called PM10, PM2.5, NO2, SO2, ozone, and carbon monoxide. They've been well demonstrated to show that they have effect on human health. Well, so luckily for us, in Cindy's area, these pollutants are measured every day. So we can just collect the data and do our own analysis and identify our own effect estimate of these pollutants on health in Cindy's area. And to do this, it's quite simple. We just do a time series analysis with a multi-pollutant approach. But that's not where the real fun is. The real fun is for us to develop this indicator, we need to have a total excess risk of this combined pollutant on health, so we can use that. It's an important parameter for our indicator. So to make it fun, imagine here that I have this coffee capsules, and these coffee capsules are going to represent the different risk, the different estimates for the pollutants that we have estimated. So these capsules, of course, you can see they differ in color. And here we have the milk. So I'm going to be a barista for. So we are going to mix the milk here is the concentration corresponding to the different pollutants. So we mix that. So we take the products, we mix this and all of that. So we might end up with a macchiato, a cafe latte, or a cappuccino. And at the end of the day, we add all of this up together, making a cocktail of coffee mixtures. This is not an idea for Starbucks, by the way. And once we are done, we then calculate the risk. We scale our finished products on low to high risk. And we give this information back to Cindy. So she would know today, this is the air quality. When it's a 3, it's a low risk for my health. When it's a 9, it's a high risk for my health. This is particularly important for people like Cindy so they can be more aware about the air pollution in their area. And that way, also manage their exposure to air pollution at the same time, and in turn, reducing the number of hospital admissions in the area. Remember, Cindy is only 16. She doesn't deserve to be in the hospital. She should be having more funds in the sun. Thank you.
This is so cool. As a coffee addict, this is actually a great analogy.
Thank you.
And also for a very important topic, a very important project.
Absolutely.
I think all the judges are very ready. Excited.
All right, thank you very much. That was a great talk, very engaging. And it's a shame you only get 3 minutes, but that's what we give, right? So my question is, the markers that you measure, is this an applicable analysis to other types of, for example, they lived close to a lead mining operation, or radioactive or whatever? Would this still be applicable, or would that be?
So this would be applicable because the first step of doing this to develop the indicator is to do the effect estimate. If we have concentration levels of lead in this area, and we have our health outcome, mortality or morbidity, we can do a time series analysis to identify what the effect estimate of lead is on health, and that effect estimate will be used to develop the total risk of the pollutants on health in the area.
Okay, that's fascinating. I hope it gets. Do you have any approval from government? Are you applying this in the real world, or are you just living behind a computer like the rest of us?
The hope is that this would be implemented in the real world, because the current indicator that is used to communicate the air quality level is not quite protective and does not adequately actually capture the effect of air pollution. So my PhD is about developing this methodology, because it's one thing to point out that there is a problem, but we should also offer solutions. So this is a solution in a methodological way, so that when the government is ready, then they can say, okay, this lady did this work, and then they can follow the methodology and adapt it to the needs of the people in the area.
It's hard to do a PhD like that, isn't it?
It is.
Yes, my PhD was simpler, so my sympathies.
Thank you.
It's very hard to prove you've discovered something new.
Thank you very much, Semitopi, for your inspiring talk. I just imagine I would be Cindy. Okay, that I think would help me lots to understand me better, so that I can choose or make decisions on what to do and about my well-being while doing so. how could you, would there be a possibility for people who are not able to decide whether they live inside or outside or work inside or outside? Can they somehow protect themselves from the damage?
So I would like to first state that the protection of one's health from things that are not really caused by them, when we talk about air pollution, is predominantly the responsibility of the government.
Yeah.
So this is just something we are putting in place in parallel while efforts are being made to clean the air, because everyone deserves clean air that does not impact on their health negatively. So this is something other people can also use, but it is essentially a tool for behavior modification. So if people are outside and this is the air quality, if with the help of their doctors, they could be advised better and say, when the air quality is this, maybe do not do such strenuous exercises out there. Maybe do not spend too much time outdoors, and just look at this, especially if they have. But for a normal human being who is fine and healthy, the message would differ accordingly. Yeah.
Great, thank you.
I have a question maybe along the lines of where Nick left you off. So do you also work with people working with sensors for pollution and things like that? Do you also work with them to see how they can maybe provide solutions to, I know you just stated the government's responsibility, but in addition, provide solutions to actually kind of purifying the local, I mean, it could be the industries that you work with, or,
So we do not work with the people, because that is a different sector of air quality monitoring. They're just supposed to monitor the air and tell us what it is at this point in time. So in essence, it's not their work to do that, but we need their collaboration to develop something like this. So it takes multiple parties and sign-ins to be involved. We need the air quality, the Department of Environment and Epidemiology and Health to be involved, so that they can see this as a need for the people, but also not be too reliant on that. Because once you say there is something people can use to protect themselves, they're like, oh, then we can live the air the way it is. So that's essentially what it is. Yeah.
Thank you.
Cool.
Great job. Again, a very, very important project, very, very timely. Finally, to close this all off, we have Jelena Simejunovic coming and closing it off with another big topic, right? How are we fighting global warming? And she's doing it with graphs. So working on her PhD in electrical engineering at both EPFL and now also working at the Sustainable Energy Center, CESM, in Neuchâtel, with the Digital Energy Solutions Group. Jelena is excited to really use this time to communicate about how her approach and her projects are really going to tackle some of these big problems in the world. So welcome.
Thank you.
Before we begin, may I ask you to increase the room temperature for 2 degrees? This question sounds silly, not because it's already really hot here, but because 2 degrees Celsius doesn't matter, but it does matter. If your body temperature increases 2 degrees, you are sick. And the same goes for planet Earth. If the global warming continues and the global temperature increases 2 Celsius degrees per year, hundreds of thousands of people will die annually just because of the heat. 99% of the coral reefs will disappear, and there will be many other consequences. So, what can we do to fight global warming? In order to answer this, let's go back at the beginning of the story. Once upon a time, people used fossil fuels, and they increased global warming significantly. Now we have a solution. We just need to substitute usage of fossil fuels with renewable energy sources, solar and wind. Fantastic, right? But there is one problem. Solar and wind energy sources for power production, they are dependent on weather conditions, which means that they are very difficult to accurately predict. And operators must have this information together with consumption prediction in order to avoid blackouts. this is where graphs will come to fight for us. Great, right? But let me show you how. Imagine cold, cloudy, windy day, and well, since it's windy, wind power production is going to be high, but solar power production is going to be low. And you are probably going to boil some hot water for your tea and use your stove, and you won't go to work using your bike, you will use your Tesla. So also you have to charge this battery, right? So do you see how weather, electricity consumption, and the electricity production are correlated? And in order to find these correlations, it is suitable that we present our data on graphs. Because if you can imagine these power sources from the production and the consumption as nodes in the graph, the links that are connecting these nodes in the graph, they're going to carry information about these correlation values. And these correlation values will help us achieve accurate forecast. Phew. Let's hope that fossil fuels will stay part of the past. And you can see how actually graphs will help us win, hopefully, the fight against global warming. And planet Earth can live healthy ever after. The end.
That was quite the reveal. Oh, it's okay. I'm a big fan of graphs. I also use it in research, or trying to use it a little bit. And Anna over there, I work with her. She's laughing at me because I can't quite figure out how they work. But yeah, let's move on to the judges. Do we have? Yeah.
Okay, then I start. Thank you. That was a really nice talk. So I have a question for you about how do you study this? I mean, how do you go about setting up questions, and how do you answer these questions that you explained in 3 minutes?
Well, so far, can you hear me? Sorry. So far, I've been focused on working mainly on PV power forecast, because we all are aware that there is more and more PV solar panel stations every day, and in order to include them more in the grid, it's really difficult to make an accurate forecast. In order to make an accurate forecast, well, the first question is how can we help grid operators, system operators, to use actually more power from the wind or the solar energy? Because we can just add a solar panel to a rooftop, but in order to balance the grid, to avoid blackouts, because too much or too low energy production both can lead to these blackouts, and we are all used to having electricity 24 hours a day. So the question is how to help them. And one of the, let's say, sub-questions of this big topic, how can we actually tackle the problem and help the operators, is to help them provide with most accurate forecast. Because it's really important. Without accurate forecast, they cannot balance the grid, and we will, well, be without electricity. Thank you.
Thank you, Yelena, for your really energizing talk. I wonder what springs to your mind when you see a cloud.
Well, for me, it's quite easy. PV. Solar. I'm thinking, where is it moving? Yes. Because if you can imagine cloud moving from Bern to Zurich, yeah, and then in Bern, it's already affecting the PV production. It's going to be low. And we know that it's moving towards Zurich, then we can say, okay, if they are correlated, Bern and Zurich, and we see clouds moving, we can actually know that at Zurich, we can make a more accurate forecast just by knowing that 2 hours before there was cloud in Bern. Yeah. And what's the most fascinating part of the story that I didn't mention, I'm sorry, is that we are trying to do this only using power production data without weather stations. Because in Switzerland, for example, we have 260 weather stations in Meteo Swiss network, but we have over 130,000 solar PV stations. So if we leverage information that we have so much, we can actually use this information to find the correlations and then infer the cloud movement, and based on that, make more accurate prediction.
Okay, now you only need to know how to make the clouds work for you.
I already work for them.
Okay. Thank you.
Thank you.
Thank you very much for that presentation. It's really eye-opening. I just want to ask, in your opinion, and not to bum everybody out with the final question of the session, but in your opinion, are we moving fast enough towards renewable energy solutions, or have we missed the boat?
I'm optimistic. I like to always believe in positive, and that's why my stories always end happily ever after. But yes, I believe that we still haven't missed the boat, and that's why in 2015, when this Paris Agreement that you probably all heard about on the news has been reached, how much degrees the water we can allow it to become hotter without destruction on all scales. It was set in so much years in advance, and it's been 7 years, and there are still many years to come. So I believe that there is still time to not lose the coral reefs or human lives, and probably many the other animal and plant species as well. Thank you.
Thank you very much.
Thank you.
That's an amazing positive note to end on. Thank you so much.
Thank you for having me.
So that's all for all 8 of our contestants, competitors, not contestants tonight. English is hard for some reason right now. Could we have everyone actually come up? That's given a talk, or actually maybe we should. Yeah. Just another round of applause for all of these amazing finalists for the Swiss FameLab 2022. Woo! And now I think it's time for the jury to go and deliberate. Yeah. Everybody did so great. Everyone wins. And in the meantime, for those of you live here in the audience and also those online, we have opened the Mentimeter link. So there's a QR code that you should see on screen or here on the slides. So with that QR code, you can also vote for your winner through that. And in the meantime, I think we can also get some questions. While everyone else is voting, are there any questions that you would like to ask each other? Any burning?
When you were just talking, said that you weren't using weather predictions per se, but I mean, I guess this is, just in like my layman's understanding, I feel like this would be a really important part to be able to understand how this all works together. So can you maybe say a little bit more about that, or?
That's a really great question. Thank you for asking it. Well, as I said to some of the jury when they asked the question, there is, for example, 260 weather stations in Switzerland, but over 100,000 solar stations. And if we actually leverage information that we have from the data, we can basically estimate the clouds without weather conditions. And what we have been doing so far, and we have shown that our solution is even better than some other that exist out there that are using weather information. Okay. Because I guess that many of you have heard this already, that the data is the new oil. And actually, I think, this is one of the examples where, although it's not accurate weather forecast, but just from using the data, we can actually estimate the weather movement. Thank you for the question.
Yeah. Actually, I have a question on the quantum computing because it involves materials. For sure, I like materials. So actually, recently I read a lot about there is a race between the countries to develop the fastest quantum computer. And is it like, how powerful is it like as comparison to the normal supercomputers we have, or is it like already done, or what is going on? And
That's a really, really good question. And in fact, I would say even within like the physics community, there's a lot of disagreement. So I mean, as you said, there's a lot of countries invested, but also a lot of companies, right? IBM, Google, everyone's trying to make the first like full quantum computer. So we do have some initial systems that are working that you can do measurements on, and they keep progressing further and further. And I would say sort of where quantum computers play a real, or will play an important role, is actually maybe not sort of the typical computations that we do. You know, you're not going to use a quantum computer to go 2 + 2 = 4 or something. But it turns out they're really good at solving very complex problems. So for example, you know, chemical systems, simulating how a protein will fold, or how various chemicals can interact. This kind of thing a quantum computer is very good at, because in a way these are already quantum systems. So you're simulating a quantum system with a quantum system. And so this is an area where it's going to be, I think, most effective. Again, there are people that are trying to create, you know, quantum processors where they claim, you know, it's going to be, you know, a few inches in size, and who knows, maybe we will have laptops that work on quantum technology soon. But yeah, I would say it's more the simulation of complex systems where it plays an important role. Yeah, but really good question.
Cool. I see audience here has voted, and I'm sure there are others online who are voting. Also, at this point in time, we can start to take some questions from the audience here. Or if you're online, we do have a YouTube chat that's live, so you can also type that in there. Oh.
Well, I have a question to the only man. At least in my field of science, yes, there is a certain majority of women doing research. That's true. But I mean, it's somewhere in the 55%. Can you tell me why men do not participate in the FameLab and only women? And you make a difference. Congratulations.
Actually, it's a quite tough question. Let's say women are powerful, maybe. For next time, I will try to encourage more men to participate.
I think actually lately it's been, I know for the last 2 years, at least my year in 2020, it was quite equal. I think thereabouts. 20.
One guy last year.
Okay, so it is maybe a trend, but we do need to, aim for equality, get everyone out there to participate, really. Any questions online? I don't? Yes, okay. All right, so we have a question for estimation of death time. Looks slightly terrified. So this is what scares you, no? So what is the maximum time that prevents to have a good estimation? I mean, if the body, for instance, is found 3, 5, 10 days later, so I guess, at what point does it's no longer effective, I guess?
Thank you. So the gold standard today is the hand skin Omogram. So this is based on the rectal temperature, and the rectal temperature needs like 48 hours max until the temperature of the body is the same temperature as the environment. So after those 48 hours, you can't estimate the time based on the temperature. Of course, there are other methods, but I guess they're out of the scope now. No, for sure. There are, for example, the rigor mortis, so how strong the muscles are, or the place, most of the time this one, and of course the putrefaction of the body can also be estimated, or insects, which are colonization on the bodies, and those factors. But I'm not a medical doctor, so.
So this is not medical advice, but it's cool. Yeah. Do we have any other questions, thoughts? Or again, any for each other? I'm also actually again for time of death. Also because you mentioned MRI, and that was also the topic of one of the talks. Whereas, there was functional MRI that's mentioned. Is it the same type of technique that you use? What is the compare and contrast your MRIs? But
So we don't use functional MRI because functional MRI is like checking the blood perfusion and where the oxygen is most at during any tasks. I hope. Yeah, and this is only in living people. So we don't do functional MRI, but we just do imaging with the MRI, so we can see any lesions or tumors, for example. Yeah.
I cannot really add much, but we also, before doing a functional scan, we also do a structural and anatomical scan just to have some kind of orienting our ways in the brain. And I think probably this is very similar, I guess. And I think what you said about if the tissue gets too cold, then also all of these effects that I talked about, for example, the relaxation of a proton that was flipped is much slower, I think. Yeah. So it is different just because the tissue has a different temperature, but generally I think the method would be similar. Just not to the functional, because that needs a living person.
Yeah. That's very cool. I don't know this, but that's why I asked. It's always good to ask questions. Yeah.
I have a question for Adele. I guess the link that you could use to tie your research on poop transplant and so on, and drugs is like the slow release mechanism, where not really. But could you tell us more about how, like, fecal transplants maybe tie into drug use and stuff like that? How the drugs of the future are going to have to tie into that?
Yes, thank you. Well, it's true that I could link it to the what you would call slow release. We call it controlled release because when you get any tablet, actually, if it's not protected with some polymer, it releases its content in the stomach. And then when you put a gastro-resistant polymer, it can release in any portion of the intestine that you would like. And it's true that with my fecal transplant microparticles, I want them to release in the colon, so I would have to use this kind of technology. I chose not to do a parallel with my research this time because that was not my message. My message was really that you take a drug, sometimes you have to take it once a day, sometimes you have to take it twice, 4 times, 6 times, and it's not just to bother you or just randomly that, oh, I would like to make people eat this 6 times. And this one time, that is not why. In the notice, it's different. But it's really because of that journey in the whole body and that the time it gets to its target and the time that the liver takes to eliminate everything is different from one drug to another. And I wanted to touch on that this time. Yes. Thank you.
So actually, the question is to you. I have read sometimes articles about the placebo effect. So if we have a headache and you give me a pill that is not aspirin 3 times a day, will it work the same way like aspirin? Does the psychology play a role? Can you just tell something?
Yes, for sure. I mean, there is a placebo effect. And this effect is different from one person to another because of your own beliefs I would say. And how much you believe in a treatment or not, how much you want to be cured or not, I would say. But yes, for sure, there is already, let's say that a drug, you take it to enhance a pathway that is already taken by your organism, but you have to boost it or to stop it, depending on the pathology. And I would just say, I'm not very versed in the placebo effect, but if you already have your body that is doing something to try to fight off a pathology, well, I mean, the thing, taking something to be reassured and just feeling like, okay, I'm taking something and I'm gonna help my body to fight off this thing that I have. And I think that's very powerful, and I think it has a relationship with the placebo effect. I would say that's where it plays a role. Thank you.
If I may add, maybe one day will be also scientifically proven. And I connect this maybe with a part of my performance, because, you know, the thoughts are also a stimuli, you see? And then if the thought can change your physiology, it's amazing.
Would you, I don't know, I'm thinking, would you imagine, could you show that through functional MRI? Could you imagine that it's like study giving a placebo versus giving an actual, Tylenol, Advil, ibuprofen treatment or something? Could this be studied in a way?
I mean, probably yes. I need to think for a moment. Well, if the drugs work that fast that you can give someone a drug, put them in the scanner, I don't know, do what with them? Ask them if they still have a headache for an hour. I don't know. Just you just need a measure to, or like a cognitive measure to determine did the drug work or not. And then I guess if you give someone a placebo and someone not, and both is the same way, and you can even compare the brain activity, you surely would find out interesting things. I guess.
Thank you. That was a really good answer to like a very wild what if question. Anything from the audience? Oh.
Well, maybe I'd like to follow up on my question, because I'm the Dean of the Swiss School of Public Health. We organize the Science Flash Talk, and we have the same phenomenon with strong propensity of women to participate. I wonder whether you, as women, could you say that there is some incentives or some motivation that you feel like, well, maybe this is something that attracts me as a woman more than my male colleagues? Because I ask it, we would like to make somehow a difference, but I have no clue how to make a change. I just realized this happens. So if you have an idea why we see this propensity of women to have fun with doing this versus men not, it would be great to know from you.
So I can speak for myself, and I'm not going to extrapolate to every woman. I think the need for science communication is stronger, particularly for me as a public health student and someone who's studying to be a public health practitioner. It's the point of like what FameLab is about, making science more accessible. And I feel like in the science community, we have the tendency to gatekeep information by making the words we use, the way we say things, just not understandable by the layman. And in public health, that is not ideal, because we do health for the public, not a specific few, not the elite, not the ones who went to great schools or better schools. So for me, it really is about how can I be in public health and communicate that science to just about anybody. So it's down to using the most mundane examples, the everyday examples to explain something very, very simple and basic. Because sometimes not everybody has the time or the capacity to download an article and read everything and understand what study material is and all of that, but just being able to give them the information and what is applicable to them in a very short sentence or a very short time, that is particularly important for me, and that's why I continue to do science communication and enter competitions to compete with you guys. Yeah.
But where is the gender point?
That's why I said I can speak about it for myself and not extrapolate to a lot of women. So, is anybody else?
I mean, it's hard to say. So for myself, being from physics, it is a very male-dominated field. And yes, it is usually, I would say in my experience, the case that it's usually women who tend to be more on the side of, I want to explain this in a simple way. Why that is, I mean, good. Having a competition like this and willingly standing up in front of people is probably most people's worst nightmare. So in general, just getting anyone to participate in such an event is a hard thing to do. And so I think one thing that one could imagine is trying to build this more into sort of a PhD program to, you know, maybe not have to present out loud, but at least, for example, if you're writing a paper, write a summary which is designed for the layperson as practice. This kind of thing, I think, helps any scientist to think about what they're doing and really go down to what is the important point, and which is exactly what we're doing here, without maybe the added nervousness and fear of having to stand up in front of people. Why it is that women tend to prefer talking in front of people than men? No idea.
Maybe I can ask a different question. Are men in fields that require them to communicate with people? So maybe that's the first place we need to start. Maybe, for instance, maybe physics, the work they do, does not require them to relay that information to everybody and just a specific field, the Ministry of Health or whatever, but maybe women are in other fields of study that they want to be able to talk about what they do to everybody, and men are just like, well, I did the work already. I left the work at home, and that's about it. I don't know, just an idea.
Yeah, I think I agree with implementing more. Again, yeah, not being able to have a proper answer, but in terms of promoting things like this, I've also been a big proponent of really pushing for everyone in academia to start to talk about their science and get it out there, because this ivory tower isolation it's not really useful for anyone, especially, 2020, I work in an immunology lab, and then seeing all of the online discourse, and then somehow within, academic Twitter, people would complain a bit or make fun of, some of the things that's said, but it doesn't help the conversation. It doesn't get people to step out there and just go into public and go, look, this is not the way that it is. We'll break it down into simpler terms without using anything too technical, without using anything too advanced. And I think we should just have more of a focus in this, whether it's part of a program or whether it's we just make things more common. I mean, we have discourse at Uni Basel and more of these, these programs. And now we have sorry.
So actually just something that came to my mind right now. So with this exhibit that I've been working on, one thing that we've done is sort of open days, where I've actually invited people from the lab, so my colleagues, to come and talk to just general visitors at the Technorama. And this has worked really well, and everyone has said, they really like being able to talk to different people and explain it on different levels, and it helps them learn a little bit about what they're doing. I think what's key there, why they're more willing to do that, is because it is an informal setting. Like, they don't have this pressure of having to stand up in front of people. It's just a one-on-one sort of thing, talking to friends, family, and general public. And so this has worked really well for us, actually. Yeah.
All right. So, jury deliberations Moreover, I think online voting is also closed. So now is the time for the results. Is everyone nervous again? Is it heart rates are spiking just across? Yeah. Oh, it's like it's done. We don't care. All right. So I guess we should start with the public vote. For the public winner, can we get sort of a drum roll around the room? It is Yelena. Our of course, everyone had amazing talks, but yeah. And is there anything you would like to?
Well, I would like to thank everybody who voted. I would like to thank everybody who voted, not for me, but for everybody, and to be included in this competition and raise awareness. And yeah, I think all the talks were really, really great. I guess audience have really difficult job. Thank you.
And now I think I'd leave it in the hands of our jury for, I guess, first, if there's some general feedback, and then we can talk about the runner-up, or and then announce the winner. If you would like to have general feedback, or.
Okay, right. So, yeah, I'm just going to be the bad guy then, because the ladies over here should be nice. So. Remember that the point of this competition is that you go on to the finals in FameLab, right? And although it's this is the second time I've done this judging business, and it's that's the one thing you need to remember when you sit outside the table and you have to deliberate about the two people who win. So the part of the judging process is to make sure that the candidate we send over, or the candidate, oh my goodness, the winner, the contestant that we send over. Sorry, I had a PhD defense thing going on. I forgot the candidate. Jesus Christ. Okay, so the contestant that we sent over will. Okay, I haven't. Oh my goodness. Will be able to handle that kind of competition and contest, right? So that really makes our job a little bit. Well, I wouldn't say easier, but it gives us some clarity, because all the talks are great, everybody's great, but we need to think about who goes over there later, right? So our choices are no reflection on the 6 people who didn't make it, or who didn't make the cut. I think the talks were great. I think your enthusiasm, we think that your enthusiasm is fantastic, and honestly, as somebody who's been doing SciComm for the better part of over a decade now, that's really what sells the project. Your enthusiasm, your passion for the science that you're communicating. The rest is just form. The rest is just, okay, this didn't work, let's do something else, that's fine. It's the enthusiasm that counts. Believe me, I've sat through 1,000 PhD defenses. Honestly, 90% of the time, the person who gets the PhD, because you're all trying that now, right? It's the enthusiasm, right? It's like, yeah, look how happy they are, man. Come on, just give it to them. That's fine. That's fine. Just screw it. Just give it to them, man. Who cares that the supplemental data is crap? Just give it to them. Right? So, that's really what you should bank. That's what people engage with. That's what people listen to. And I think you all get top scores on that, right? You all are enthusiastic about what you communicated. So you've all won in that aspect because you figured out the key to science communication. You need to like what you're talking about. That's it. Believe me, I write things that I don't like, and you can tell. And my editors can tell, but that's my job, whereas you guys get to do this for free. Right, so should I let somebody else do the announcements? Because I just feel like the butcher up here. Anyway, you guys were great, and you did a really good job, and you should be proud of yourselves for making it up to here. And whatever happens here, just don't let that discourage you from pressing on. We need science communicators. We need people who can make this arcane world of data and graphs and sometimes long, boring stuff interesting to the public, because people need to be educated in science more than ever today, really more than ever today, right? So thank you all for participating, and I'm going to let one of these ladies do the honors.
Yeah, first of all, a big heart for all of you, for everyone. It was amazing to take part in 8 different universes. Thank you very much for that. And how should we do that? Who's first? Shall we sing it? Shall we count to 3 and then say runner up? Okay.
He's delegated this bit to us. Okay, we can do it together.
Okay, so the runner up of today is Temi Toby. And the winner
the big
of the Swiss final,
representing Switzerland.
Yes.
No pressure.
2022 is Natasha! Woo!
Sorry, now there's pressure.
Oh no, please no. No, honestly, thank you so much. It is such an honor, and I'm so much looking forward to representing Switzerland. It's been a fantastic opportunity to do this and experience, and also getting to know everyone here. I mean, everyone did such a great job. I don't want to be sitting where you are right now because I wouldn't want to have to make this decision. And yeah, so thank you to everyone who organizes this, because it is a great experience, even if we're super nervous and think to ourselves, okay, never again. But no, it's fantastic, and thank you so much. Thank you.
Thank you all so very much, and thank you for judging, and thank you to everyone I've had to compete with and also be in the training sessions where it has made it so worthwhile. And the entire journey has been great. I've had a lot of fun, and I will continue to have a lot of fun with science communication. So yeah, that is it for me. I'm just glad I can breathe now.
So, once again, thank you all for such a great night, all of the wonderful presentations. Thanks to such a great jury judging panel. You've all asked some really great questions, really liked all the feedback that you were giving to our competitors. Thanks to the audience, members from the British Embassy coming and being here with us tonight, everyone on YouTube, who's still there and hasn't immediately left after finding the winner. Thank you all for being here. Thanks to the whole crew and everyone, all the hard work that it took to make all of this happen. And yeah, that's it for the finals of Switzerland's FameLab 2022. And now we need the rendition of the song again to end.